Welcome to the Abundance Academy. Yesterday we had a class, but the attendance was not good, so we didn't do much. One of the things that I've agreed that we're going to do is we'll start with semester 1 work. Semester 1 work, where we'll look at sets. Under sets, we are talking of sets, complex numbers, and we are talking of surds. We are talking of binary operations. And then we'll look at functions. And then we'll go to other functions. We'll go all the way up to polynomials. Once we're done with that, then we'll go straight to trigonometry. And then after that, we'll give another directions and we're done. So we'll take our time here during this break to make sure that as we open, we're on the same page with the school. Same page with the school would have started trigonometry as we open. And we'll touch it very well, that when the school adds up, it will make sense to us. Because there's no point of going so far from the schoolwork, because sometimes they cut the syllabus looking at the time that is remaining. So you can end up doing vectors here, and then vectors are not done. If you look at the course outline, we're supposed to do binomial before trig, but then trig has come in before binomial. So that one makes the big trick for us to move faster than the school due to certain limitations. So that's our agreement here. Now the best way of looking at this is by using the very test that we wrote to try and cover up this space here. So as we cover up, because we did something, so as we cover up, I will be able to bring out important points that we need to know. So we'll start with sets. When I say sets, we are doing sets, complex, surds, binary, any question that comes in the revision. This is the revision class. That said, we'll go straight to sets. Examples. So 1, A, consider the sets A, 3 to 14. This is included. B, negative infinite 5. C, negative 5 to 7. Okay, so you should be able to get me now. And the universal set is R, set of real numbers. Find the following sets and display on the number line. I lost that thing again. What is happening? Just random. You must be able to see now. Okay, find which sets, find the intervals 1, B minus C, 2, A complement intersection B minus C, 3, A union B complement intersection C. Solution. Now, part 1, B minus C. B minus C is the same thing as B intersection C complement. Because we need C complement here, we must find it from C. So we are given C to be from -5 to 7. So what we do is, to get C complement, we go to the universal set. The universal set is from -infinity to +infinity. So go to the universal set from -infinity to +infinity. You start from the left of the universal, -infinity. Go all the way up to where you find C. We find C at -5. Open here and closed. Because -5 is not included, we include it in the complement. Union, because 7 is not included, we include it in the complement. All the way up to +infinity. So this is the complement now. So what we'll do is we'll say, okay, what is B intersection C complement? So we have B here, -infinity up to +5. Intersection, we open -infinity up to -5. We close union 7 up to +infinity. That, what does this mean? So now we want the intersection of this interval and this one. Now this interval here has 2 pieces. The first piece versus the interval on the left. Between -infinity and the other -infinity, our target is to get the bigger number. When you are doing the intersection, get the bigger number here. So now these are equal, -infinity, that's equal, so we get n of them. Then between this 5 and this -5, here we get the smaller number. Get the smaller number. Meaning the smaller number between 5 and -5 is -5. We get it as it is included. That's the intersection of these 2 intervals. Then now we extend this to the other interval, this interval versus the other interval. We wish to do the same thing. Between -infinity and 7, we get the bigger one. So the bigger one is 7. Between 5 and infinity, we get the smaller one. Now the smaller one is 5. But an interval does not move in the reverse way. It moves in ascending order. It starts with the smaller one to the bigger one. Now this one is attempting to start with the bigger one and then go to the smaller one. So this means that at this point, we have empty set. So between these 2 intervals, connected by the blue line here, we have an empty set. And because you're getting the union, so you're saying union empty set. So what we have then becomes from -infinity up to -5 as the solution. As to display on the number line, you display the final solution. So you display up to -5. So here, all the way up to infinity, -infinity. This is B minus C, the displayed solution. So that's the easiest way of getting this. Most of you were attempting to use the intervals, and in the intervals, they are making so many mistakes. So I want to see if you are able to use this shortcut. I'll give you a task, and I will expect you to use this and just use the number line to display, not to use it to solve. So agreed on that one. Then we go to part 2. Part 2, we have A complement intersection B minus C. Now A runs from 3 to 14 included. So the complement of A is then going to be from negative infinite up to 3. 3 is not included in A, so it will be in the complement. Union, we leave out 14 up to positive infinity. Then now we get back here and say A complement, which is negative infinite up to 3, union 14 to positive infinity. This intersection B minus C, we just found B minus C here. So we have negative infinite to negative 5, negative infinite to negative 5. So again, we get back the same thing. So between negative infinite and negative infinite, we get, so on the left, because of this intersection, we get the bigger one. The bigger number, that is going to be, because we have the same, we have a negative infinite. And then between 3 and 5, between 3 and negative 5, we get the smaller one. Here we get the smaller number. So we'll have negative 5. Negative 5, as it is, it's included here. And then union, so the next interval between 14 and negative infinite, we get a bigger one. So the bigger one is 14, as it is, comma, between infinite and negative 5, we get the smaller one. The smaller one is negative 5. Again, this interval does not make sense because it's in a reverse form. So we have negative infinite up to negative 5, union empty. Because it's empty, we get negative infinite up to negative 5 as the solution. On the number line, up to negative 5, we go to the left. That's how you present it on the number line after you have solved. Precious.
Sir, there you said that the reason why we're getting the bigger number in it's because there's an intersection there in between.
Yes.
What if there's a union?
Okay, part 3 will demonstrate on the union.
We get the bigger one and the smaller one.
Hold on a bit. When you do part 3, you'll see what happens on the union.
Okay, sir.
So you go to part 3. So I'll do it from here so that we can have an easy view here. A union B complement intersection C. So A union B complement intersection C. So we have A, it's 3 to 14. Union B complement, what is B? B is from negative infinity to negative 5. So B complement is then from negative 5, not included, up to positive infinity. B up to positive 5, I mean. So comma positive 5. And then the complement is from 5 to positive infinity, like this. Then now you say, okay, we bring it here now. 5 to positive infinity. Here we are finding A union B complement. Because it's union. So because it's union, we say between 3 and 5. For union, we get the smaller one. We get the smaller number. And then between 14 and infinite, we get the bigger number. On a condition that you have checked that this number on the right is smaller than the one on the right here, then you are sure that they will intersect. Then I can pick now a broader union. Meaning, here now we have the smaller one is 3, pick it as it is. The bigger one is infinite. This becomes A union B complement. Then this one now, A union B complement intersection C. So we're saying from 3 to positive infinite intersection. What is C? C is from negative 5 to positive 7. We are now in the intersection. So between 3 and negative 5, we get a bigger one, which is 3. Between infinite and 7, we get the smaller one, which is 7. So on the number line, we display 3 to 7. None of them is included. That is how it gets nice. So agreeing that we need to try we try this method and just get to the number line to display. I give you a follow-up task. Let A run from negative 7 to positive 7. B run from 0 to positive 5. And C run from negative 5 to positive 1. B subsets of the universal set of real numbers. Okay. Find the set A minus B minus C expressing your answer in interval notation. And displaying it on the number line. Not use the number line only to display and not solving. Meaning, I want us to use this method here. The number will just appear when you're displaying the solution. So I want you to use the shortcut and then see if it will make sense. Okay. Do you have any question? No questions. Good. So this was example 1. We go to example 2. Example 2. Let Z1 be to I, Z2 5 minus 3I, Z3 2 plus 3I over 3 minus 2I. Find 1 Z2 minus Z3, 2 Z2 over Z3 minus Z1, and 3 the root of Z1. Solution. Part 1, we want to use Z3. But look, Z1 and Z2 are in a normal form. No fraction, no I in the denominator. So go to Z3 first and deal with it. So let's conjugate Z3 and see how it will look like. 3 plus 2I, 3 plus 2I. This will give us 6 plus 4I plus 6I, plus 9I. When you multiply 3 by 3, and then I times I, we get -1. Then 3 times 2, we get -6 over 3 times 3, we get 9. 3 times 2, we get 4I. We get 6I. We get 6I, and then minus 6I, then plus 4 because of the I. So 6 minus 6, we get 0. 4 plus 9, we get 13I on top. Down 6 minus 6, 0. We get 13, which is equal to I. What you're saying here is that Z3 is actually equal to I. Now we can go on and find Z2 minus Z3. This is going to be 5 minus 3I minus, what is Z3? Z3 is I. So we get 5 minus 4I. It's done. Part 2, Z2 over Z3 minus Z1. This is the same thing as, what is Z2? Z2 is 5 minus 3i. Or what is Z3? Z3 is I. So we'll put I here, minus Z1. Z1 is 2i. So this whole thing is 5 minus 3i over negative I. To conjugate, we multiply by I and the top part by I. So we get 5i. I times I, we get negative 1 times the negative 3, so we have positive 3. Over negative I times positive I, we get positive 1. This is 3 plus 5i. Simple, like that. Then we go to part 3, the root of Z1. So we must express, oh, the question again. So we just said let this, then find the root of Z1. Okay, so you say, since I'm finding a root Z1, Z1 is 2i, so we're finding root 2i. Well, suppose the answer that we find, because it's a complex number, suppose that answer is going to be in the form x plus iy, meaning it will have the real part and the imaginary part. This be equal to 2i. But when you square the right hand side and the left, you get x plus iy multiplied by x plus iy is equal to positive 2i. This will give us x squared plus 2xyi and then minus y squared. When we expand this, so we multiply x times x, x squared, x times y, xy, y times x, xy, and add the two to get to xy, then y times y, y squared, I times I, negative 1 is equal to 2i. Then you have x squared minus y squared is equal to, on the right hand side, we don't have any number that is without I. So this is equal to 0. And then 2xy is equal to 2. Yes. So now we concentrate on this one. So we get xy is equal to 1 when we divide by 2, meaning y is equal to 1 over x. So y is equal to 1 over x. So that when we come here where there is y, we substitute. So we have x squared minus 1 over x. Because y here is squared, we squared here too. Is equal to 0. Giving us x squared minus 1 over x squared is equal to 0. If we multiply throughout by x squared, we get x4 minus 1 is equal to 0. This means that we have x4 is equal to 1, implying that x is equal to plus or minus 1. Because x4 is like x squared squared. So we get two values there. Then we just say that y is equal to 1 over x. So meaning that y is equal to 1 over plus or minus 1. Y is also equal to plus or minus 1. Meaning we have two options. So we can say, well, the answer we are getting is x plus iy, which is a complex number. Suppose it is equal to z. So we have z is equal to x plus iy. When x is +1, y will be +1. That will be I. Or when x is -1, y will be -1. So we multiply it by I, becomes -I. Here are the two values expected. Because we know that two complex numbers are equal if and only if they are real and imaginary parts are equal. So a very simple follow-up exercise here. Express 1 plus 2i over 1 minus I plus 1 minus 2i over 1 plus 3i in the form a plus bi, where a and b are real numbers. This is 1 and 2. Find z is equal to a plus bi if z is equal to the square root of -3i. So find z is equal to a plus bi, meaning find z in the form a plus bi if z is given as -3, the square root of -3i. So here you're applying the direct applications of what you're doing here. 1 and 2 are combining together to solve question 1, and then part 3 we are solving question 2. It must be easy to do so because you have an example before. We're supposed to do this longer than this period, but we won't go that far. I'll give you time to do the task. Yes. Okay, so we end here.